All right, so now I want to look at another example where where we have a higher order equation. So I give you, we're going to do the example of, we're going to start with the fourth derivative of u minus u equals 0. Okay, and I want you to write it as a matrix system. And then find the solution of the matrix system. And then finally, we want to write down u. Okay. So this is an alternate method for doing this. And in lots of applications, you actually do want to view it as a matrix system. Okay. So there's basically a set trick to doing these higher order equations when you're handed one higher order equation and you just say, write it as a matrix system. Here's the trick. You take x1 to be the unknown function. Okay. And then you take x2 to be x1 prime, which is u prime by the top line. Okay. And x3 to be x2 prime, which is x1 double prime, which is u double prime. Okay. And then x4 will be x3 prime, which is u triple prime. Okay, because it's his x3 is equal to this, so x3 prime is just u triple prime. Okay, and then notice x4 prime is going to be what? X4 prime is going to be the fourth derivative of u, because well, I should say x4 prime will be x3 double prime, which is another prime on this guy. So that's four derivatives on u. Okay. And then notice by the equation, what is u fourth derivative? So by the equation, x4 prime, which is the fourth derivative of u, is equal to u. So that's x1. Okay. So you start with u, you get all the derivatives all the way up to the n minus first derivative. So here's the third, it's a fourth derivative, is your highest order derivative. X4 will be the third derivative. And then x4 prime takes care, the next one takes care of the equation. All right, so I'm going to let x be x1 to x4. Okay, and then x prime is x1 prime, x2 prime, x3 prime, x4 prime. And I want to find a. So that x prime equals ax. Okay. Now x prime, I just wrote down. And I want that to be the matrix A times the vector x. Okay. And now I have to use my equations up here to figure out what the components of A are going to be. Okay. So let's see. Let me switch pens. This pen just ran out of ink. Okay. So what do we know from up top? We know that x1 prime is equal to x2. So that means in this first row, when I multiply, what entries do I need here so that when I multiply times this matrix, I get x2. For the first row, I have no choice but this if I want to say x1 prime is equal to only x2. I need a 1 there and zeros in the other slots, and there is no choice. There's no other choice that would work. So that makes the first row say x1 prime equals x2. Okay. And now by the equations up top, x2 prime is equal to x3. The second row is going to be x2 prime. And so I need to pick my entries here so that when I multiply the second row times this column vector, I only get x3. Again, there's only one choice that will work so that I get x2 prime is equal to x3. Same game now, x3 prime is equal to x4. So x3 prime, when I need entries so that when I multiply times this column vector, I only get x4 and nothing else. And that way it says x3 prime is x4. And now what is x4 prime? The last one always comes from the equation. x4 prime was u fourth derivative. And by the equation, the fourth derivative of u had to be equal to u, but u was x1. So I want x4 prime to only give me x1. So this is the differential equation that I have x4 prime equals x1. So which numbers here would make it so that when I multiply times this column, I only get x1. Again, you have only one way you could pick it. Okay. So here's how you set it up as a matrix equation. Now we figured out what A is. Okay. And now we have to solve this. So we have x prime equals ax, and we found A. That's step one. That write it as a matrix system. That is find x, A, and x. Okay. So we did that. Now we want to find the general solution of this matrix system. So now we start on that part. So you find the eigenvalues. Okay, so that gives me minus lambda. That means I'm subtracting 1 off the main diagonal. 0 minus lambda, 1, 0. 0, 0 minus lambda, 1. And then 1, 0, 0 minus lambda. Okay, and I take the determinant of that, and then I set it equal to 0. Okay, that's a 4 by 4 matrix. That would be rather miserable, except that there's a lot of zeros in here. So you could go either across the first row or down the first column. Any row or column would work. So what do you get? You get minus lambda, and now you delete the row and the column containing the minus lambda. So I'll have to take the determinant of the 3 by 3 matrix. Okay. And then the next one gets a minus sign. So I get minus 1 times, delete the row and the column containing 1. So that'll give me 0, 1, 0. And then in the next row, I will get 0 minus lambda, 1. And in the bottom row, I'll get 1, 0 minus lambda. Okay, and now you have 2 3 by 3s you have to find the determinant of, but that's not too bad because again, they have a bunch of zeros. So I get minus lambda, and I'm going to just use this first column because that's going to be the best for me. So then I will get, when I go to find the determinant of this 3 by 3, I get minus lambda times the determinant of the matrix I get when I delete the row and the column containing that. So that will be minus lambda, 1, 0 minus lambda. Okay, and then 0 and 0. So that's it. Okay, And then here I have minus, and now let me use the first column because that's got a lot of zeros in it. You could use the first row too, but the first column will, it's a plus 0, a minus 0, a plus 1. So it'll be 1 times, delete the row in the column containing 1, and you get 1, 0, minus lambda 1. Okay. So let's see, that says I have lambda squared here in the first term. Then I have lambda, another lambda squared. So that gives me a lambda to the 4th from this first one. And then I get minus, for this one, I will get minus 1 minus 0. So it's lambda to the 4th minus 1. Okay. All right. And so that factors to lambda squared minus 1, lambda squared plus 1. And so that says my eigenvalues are lambda equals plus or minus 1, and from this one I get plus I and minus I. So I get 4 eigenvalues, okay? And now I have to find all those eigenvectors. Okay, so let's see. So we'll take lambda, let's find x of 1. That'll be the one that goes with lambda equals 1. So I need a minus I times x1 equals 0. So a minus I, where's your a minus? If you look up here, you have written a minus lambda times the identity. So now look at that and take lambda equals 1. So this gives me minus 1, 1, 0, 0, 0, minus 1, 1, 0, 0, 0, minus 1, 1, 1, 0, 0, minus 1. And now my x has to have 4 components. Let's call them x, y, u, and v. And that has to be the 0 vector. Okay. All right. So now how do you solve that? You put it in a big giant matrix, because that's 4 equations and 4 unknowns. You can write those out. But now you have to solve for x, y, and z, and that ends up that you end up putting this in the big giant matrix. And using row reduction. And it's not so bad because there are so many zeros. So to get rid of the first row, let me go minus row 1. That's 1 minus 1, 0, 0, 0. And then the second row is in good shape, but I'm going to go ahead and multiply by minus row 2. So that'll give me 0, 1, minus 1, 0, 0. And let me go ahead and do minus row 3 while I'm at it. So I'll get 0, 0, 1, 1, 0. I'm sorry, 1 minus 1, 0. And then here I'll do, you can either do the old row 1, or here I'll do minus 1 times the new row 1 and add it to the old row 2. So it works out that you're getting 0 here, and then you get minus 1. And then you get 0, and then you get minus 1, and then you get 0. Okay. All right, and let's see. Then the next thing we have to clear is the second column, which we already have in good shape. Okay, and now to get the 0 here, you add row 1 plus row 2. So I'll get 1, 0, minus 1, 0, 0. And the third row is already in good shape. And the fourth row, you say row 2 plus row 4. Okay, you'll get 0, 0, minus 1, minus 1, 0. And then the last thing to do is to clear the third column. Okay, hopefully the last thing to do is to clear the third column. So we will get 0, 0, 1, minus 1, 0. Okay, and now hold on, I'm afraid I made a mistake somewhere. Let's see, let me be careful. 0 minus 1, 0, 0, 0 minus 1, 1, 1, 0 minus 1. Okay. And now I add, so that gives me, let's check, let me be careful. I think I made a mistake. No, I must have made a mistake somewhere. So this is this, that gives me that, that gives me that. And now I add row 2 and row 1, that'll give me 0. That this, okay, this should have been a plus 1. Sorry, that was a plus 1. I did that arithmetic wrong. Okay, and then now it's okay. So that means I had to say minus row 2 plus row 1. So that will give me a 0 and a minus 1 and a plus 1 is 0. And then it'll give me a plus 1 and a plus 1 here. And then I get 0 and minus 1. Okay, there we go. All right, and so now if I add row 3 and row 4, that'll get, or I say minus row 3 plus row 4 rather, 0, 0, 0, 0, 0. I knew that had to happen and it wasn't happening. That's how I knew I had made a mistake. Now I know I'm okay. And now back to clearing that third column. So to get rid of this minus 1 using the plus 1, it's just row 2 plus row 3. So that'll be 0, 1, 0, minus 1, 0. And to get rid of the minus 1 using the plus 1, it's just add row 1 and row 3. So you get 1, 0, 0, minus 1, 0. Okay. And so now the top row says, translating back, remember these are equations, these are the coefficients of x, y, u, and v. So the top row says x minus v equals 0. The second row says that y minus v equals 0. The third row says that u minus v equals 0. So in other words, x equals y equals u equals v. Okay, so if you pick one of them, then the other three are determined. So x1 can be 1, 2, 3, 4. Okay. Okay. All right. Now, if you do, and now you we'd go through, I suppose we can go ahead and do this. This is going to be a bit long, but that's okay. Now we do x minus 1. So we do the same sort of thing. So now we have to do a plus I, x minus 1 equals 0. Because you have to say a minus the eigenvalue, and the eigenvalue I'm looking at is minus 1, okay? So that gives me the matrix equation. Again, looking back at my a minus lambda I, and now lambda is minus 1, so that gives me 1, 1, 0, 0, then 0, 1, 1, 0, then 0, 0, 1, 1, then 1, 0, 0, 1 times x minus 1. Again, I've run out of letters, so I'm just going to call it x, y, u, v. And it has to be equal to 0, 0, 0, 0. Okay, so that gives me another system to use row reduction on. Okay, so again, let's go quickly. Okay, so we go minus row 1 plus row 4. That'll give me 0, minus 1, 0, 1, 0. Here we're good. Here we're good too. Now we get rid of the second column, or get rid of the ones in the second column using this one. Okay, so to get rid of the minus 1 down here, I just add row 2 and row 4. That'll give me 0, 0, 1, 1, 0. The third row, I just recopy. Notice they're the same, so that's good. That will give us the row of zeros that we're looking for. And now to get rid of this one, I say minus row 2 plus row 1. Then I'll get 1, 0, 1, 0, 0. Okay, so sorry, minus 1. Minus row 2 plus row 1. So that's a minus 1. Okay, and now here I just say minus row 3 plus row 4, and that'll give me all zeros on the bottom. Okay, this row I leave alone. Okay, and to get rid of the 1 up here, I just add row 1 and row 3, and then I'll get 1, 0, 0, 1, 0. And then here, if I'll have to do minus row 3 plus row 2, and that'll give me 0, 1, 0, minus 1, 0. So this row says X is equal to minus V. That's not readable. This row here says X plus V equals 0. So in other words, X is equal to minus V. The second row here says that Y is equal to V. And the third row says that U is equal to minus V. So my second eigenvector, if I pick V equals 1, then Y is 1 and U and X are minus 1. Or any multiple of that is an eigenvector. Okay, 2 more to go. Okay. All right, so the next eigenvector is I. So I have to do A minus I times the identity times xi equals 0. So now let's go back to our A minus. Here's our A minus lambda. So this one's going to be minus I 1, 0, 0. 0 minus I 1, 0. 0, 0 minus I 1. 1, 0, 0 minus I times x, y, u, v has to equal 0, 0, 0. Okay. Okay, so I write it in one big matrix. While I'm doing that, I'm going to go ahead and multiply the first row by I. That'll give me a 1, then an I, then a 0, 0, 0. Okay, so I know I would have to put this matrix in with all the zeros. I got so much work to do on these, and we've been doing so many of them, we can skip some steps, okay, while we do it. And then now we have a 1, and to get rid of this 1, I can go minus 1 times the new row 1 and add it to the old row 4, where the old row 4 is just coming from this. So that will give me minus 1 and plus 1 is 0, minus I, and 0 is that. 0 and 0 is 0, and 0 and minus I is minus I. And then I have a 0. And I copy down these 2 rows, but I'm going to go ahead and multiply those rows by I while I'm at it to get the ones in the right place. Okay. All right. And so now to clear out that third column, wow, I didn't leave myself much room there. Okay, I do I times row 2 or minus I times row 2 and add it to row 1. That'll give me 1. Then I'll get minus I and plus I is 0. When I multiply minus I times I, that will give me plus 1. And then I get 0 and then 0. These always stay zeros, as you know, as you've noticed, I'm sure. Okay, this row is good for this stage of the game. This row is good for this stage of the game. And now to get rid of the minus I here, I multiply the second row by I and add it to row 4. So when I do that, I'll get 0. I'll get 0. I times I gives me minus 1. and then 0 and minus I gives me minus I. And now you notice these two rows are the same. If you multiply the third one by -1, you get the fourth one. So we'll say row 3 plus row 4 to get rid of that fourth row, which we knew had to happen or we made a mistake. And now to clear out that third column, all I have to do is use this row 3. Okay, so I will say for this one, I'll do I times minus I times row 3 and add it to row 2. Okay, so that'll give me 0, and that will give me 1, and then minus I and plus I is 0, and then this gives me a -1. I'm sorry, I squared gives me -1, but there's a minus sign that gives me a +1. Okay. And then finally, to get rid of the 1 here, I just do minus row 3 plus row 1. And I'll get 1, 0, 0, minus I, and 0. So the first line says U is I times, I'm sorry, X is I times V. The second row says that Y is minus V. And the third row says that U is minus I times V. So here's X sub I. If I pick V to be 1, then U is minus I times that, Y is minus 1 times that, and X is I times that. Okay. And one more to do. I thought it would be good for the soul for us all to do a big one to get a big matrix together. Okay, so this is lambda plus I to find this guy equals 0. Okay. So now you look back to your matrix with lambda, where you did A minus lambda I, and you have plus I instead of minus I. So that's going to give me the matrix I, 0, 1, 0, 0. Whoops. Okay. Then I'll get 0, I, 1, 0, 0, 0, I, 1, 1, 0, 0, I. We'll call the same letters, X, Y, U, V. And that has to be equal to 0, 0, 0, 0. Okay, and now we make it into a, that gives me 4 equations and 4 unknowns, which I make into a big matrix to solve. But because we've done so many of these now, I'm going to already get some of these in better shape as I start. So I'm going to multiply by minus I on times row 1. Then I'll get 1 minus I, 0, 0, 0. Here I'm going to multiply by minus I. So I'll get 0, 1 minus I, 0, 0. Here I'll multiply by minus I. Okay, so I will get 0, 0, 1 minus I, 0. And then here I'm going to use the 1 up here to get rid of it. So I'll do minus times the new row 1 plus row 4. So minus 1 and plus 1 is 0, plus I and 0 is I, 0 and 0 is 0, and 0 and I is I. Okay. Okay, and now to clear out the second column, I'm going to leave this guy alone. To get rid of the first I minus I up here, I'll do I times row 2 plus row 1. That'll give me a 1, a 0. This will give me a plus 1 and a 0 and 0, because I get minus I squared, so that gives me a plus 1. You just got to be careful with your arithmetic. This third row is in good shape. And now the fourth row, I have to do minus I times row 2 and add it to row 4. So I'll get 0, 0. This gives me a minus 1. And then here I'll get 0 and I is this equals 0. That's good because you can see the last one is minus 1 times the third row. So I can just add row 3 and row 4. And then I get my row of all zeros, which I knew I had to have. Okay. And now to get this one, this column is in, I mean, this row rather, is in good shape. Has a 1 in the right spot to get rid of that minus I. I do I times row 3 plus row 2. That'll give me 0, 1, 0. This is plus 1 and 0, 0. And then to get rid of the 1 here, it's minus row 3 plus row 1. So I get 0, 1, 0. That gives me 0. And then I get plus I, 0. So the first row says that x is minus I times v. Second row says y is I times, I'm sorry, is just v minus v. Okay, and the third row says u is equal to I times v, and then v is whatever it wants to be. So x minus I, if I pick v to be 1, then u is I times that, y is minus v, and x is minus I times v. So there's my third fourth eigenvector. Okay. So, so now let's put all that together. Okay. So we found all the eigenvalues and eigenvectors. Now we write down the general solution. So x of t is C1 times e to the t. So this is when lambda is 1. And now let's see, what was our eigenvalue for 1? Here was the eigenvector for the eigenvalue 1. So it's e to the t times 1, 1, 1, 1 plus c2 e to the minus t. And now I need the eigenvector that went with minus 1, which we found here, one version of it is minus 1 plus 1 minus 1 plus 1, or any constant multiple of that would work. Okay, and then I get C3, then we had the eigenvalue I. So this is e to the it times the eigenvector that went with that. Plus, whoa, okay, this is going to be very crunched. C4 e to the minus t times the eigenvector that went with that. Okay. All right, so this is one way to write the general solution. Oops, this should have been an e to the minus it. Okay, we could also play around with those last two terms, and you could write that as, if you looked at C3 e to the it times this guy plus C4 e to the minus it times this guy, then writing out this would be C3 cosine t plus I sine t times I minus 1 minus I1 plus C4 e to the minus it. I'm sorry, that should be cosine t minus I sine t. Sorry, in there. And times the eigenvector that goes with that. Okay, so now we look for the real and imaginary parts. So we have, and for the real part in the first line, you have a C3 I times sine t. So that is minus C3 sine t. The cosine one's going to have an I in it. And over here, you will have C4 times minus I times minus I. That will give you a minus 1. So this will be a minus C4 sine t. Okay. And in the second component, now the real part will be C3 cosine t with a minus sign. And then the real component from the second one over here will be minus C4 cosine t. Okay. And then from the imaginary part, the real part of the third component, you will get a C3 sine t, and then you'll get a C4 sine t. And then from the last component, you will get C3 cosine t plus C4 cosine t. Okay. So notice if you let C1 hat be C3 plus C4, or C3 plus C4, then this piece, just writing that I have to do more. This isn't complete. Oh, I'm sorry. Okay, I'll give you a chance to look at that. But now what? So this is not complete because I still have to do the I times part. Okay. Let's do the I part of this one. Okay. And when we do the imaginary part of all these terms, okay, so the ones that'll have I, you'll have a C3 cosine t here, and then you'll have a minus C4 cosine t. Okay, because I factored out the I. Imaginary part in the second line, it's going to be C3 sine t, and then this will be a plus C4 sine t. Oh, let's see, that's not right. It's the imaginary part in the second line will be minus C3 sine t, and then minus C4 sine t. Yeah, that's right. No, something is wrong here. This will be minus C3 sine t, and then here, this is C4. You get a minus I and a minus 1, so that gives you a plus I. So that should be plus C4. There we go. Okay. And the imaginary part in the third term is going to come from minus C3 cosine t. And here it will be plus C4 cosine t. And now the imaginary part from the very last row will be C3 sine t. And over here, it will be minus C4 sine t. Okay, so I'm going to let C1 be C3 plus C4, and I'll let C2 hat be C3 minus C4. Okay, and then I can write this as noticing that this is minus C3 minus C4 times sine t. This becomes minus C1 hat sine t. Here, this becomes minus C1 hat cosine t. This becomes C1 sine t. And this one becomes C1 hat cosine t. Okay. And then over here with that substitution, this is I times, with C2 being C3 minus C4, this is C2 hat cosine. And then this is minus C2 hat sine. And then this is minus C2 hat cosine. And then this is C2 hat sine. Okay. And so you can pull out the C1 hats and the C2 hats. So this is, whoops, okay, that one just went on the floor, but that's okay. So this is minus sine t, minus cosine t, sine t, cosine t, plus I C2 hat, cosine, minus sine, minus cosine, sine. So here's u, this is u plus I times v. So now your general solution, combining that last line with what we had up here and replacing these last two so we get something completely real valued, then becomes x1 of t is c1 e to the t times 1, 2, 3, 4 plus c2 e to the minus t times minus 1, 1, minus 1, 1 plus c1 hat times um, sine t or minus sine t rather, minus cosine t, sine t, cosine t, plus c2 hat times cosine t minus sine t minus cosine t sine t. Again, using the fact that over here, this is, you think of this as a capital U plus I times capital V. And as long as X satisfies a matrix equation and X can be written as U plus IV, then U and V satisfy the same equation. So that's using this, okay? All right, so I just wanted to show you one of the problems that really takes a while to calculate, and sort of from beginning to end. So that you had an equation, a fourth order equation, you write it as a system, you find your eigenvalues and eigenvectors, then you write it, you write down the general solution, and if there are complex eigenvectors, you got to get it back to real value functions. So it just takes a while. These are very long problems. If you look at how long that took, that was quite a few minutes on that one thing. Of course, one of the reasons it took so long is because this was a fourth order equation, which led us to a 4x4 matrix. But it's good to see how it works in this bigger example. On the final exam, you won't have anything larger than a 3x3. So, okay, now you should head to the homework problems for this section. And the next lecture will be on repeated eigenvalues. Okay, see you soon. Bye.